Hello everyone. Welcome to the solution of LeetCode problem 980 named Unique Path 3. In this problem, we are given a grid of n by m and each of the grid cell contains an integer value. If the grid contains the value 1, that means it is the starting square. And there is exactly one starting square in the given grid. And if the value presented in the cell is 2, that means it is the ending square. There is exactly one ending square. And 0 representing the empty squares that we can work, and -1 representing the obstacle that cannot be worked over. Anyways, the problem statement is, at first, we are given a starting position and a ending position. Now, we have to return the number of 4 directional walks from the starting positions to the ending positions, where each of the walk visited all of the empty cell in the grid. Anyways, the problem statement may be a little bit of difficult right now, but I will explain it later. Here in the first example, suppose the robot is presented in the first cell. It can move in the 4 direction. Either it can go up, down, right, or left. So one possible way to reach this flag position or the ending position, which is by using this path. Let's follow my cursor. This is one possible way. And another possible way is that, again, follow my cursor by using this path. So this is two possible way. So in this case, we have to return 2. Anyways, I am explaining this example and the algorithm later. I hope you understood the example. Now let's move on to the algorithm. Now, according to the problem statement, in the first cell, I have the robot, and in this cell, I have the flag, or it is the ending positions. So here, the robot can go in the 4 direction. Either it can go right, down, up, or left. So there are 4 possible ways for a robot. Now, in one possible ways, the robot can reach to this flag position is that by using this path. Here, the robot visited all of the cell exactly 1 times, and it did not encounter this obstacle cell. So here, it is one possible way that can utilize the robot to reach to the final positions. One possible way is that the robot can go to the right positions here and move to the down and move to the left and move to the down and again move to the right and finally reach the ending positions here. So it is one possible way, because in this path also we have visited all of the empty cells and did not encounter this obstacle cell. So we can say that for these test cases, there are 2 possible ways in which the robot can reach to the destination cell, where each of the path contains all of the value or all of the empty value presented in this cell, and each path did not encounter any of the obstacle presented. I hope the problem statement is little bit of clear right now. Now, how can we solve this problem? This problem can be solved by using depth first search algorithm. This is a typical graph algorithm. And in this kind of algorithm, we have to traverse the cell by using any of the DFS or BFS algorithm. So let's see how can we solve this problem by using depth first search. Suppose currently we are presented in this starting cell. Now from here, I can go either right or down. I cannot go up and left because there are no other cell presented there. So I can go only right or down. Now, if suppose I am moving to the right position right now, and if I present it here, we have to mark this cell visited. Why we have to mark this cell visited? Suppose currently we are presented here and we have marked this cell visited. Now, suppose we have go to the downwards position. Now, from these positions, I have 4 choice. Either I can go right, down, left, or upwards. But wait, do I need to go upwards or it is necessary? Exactly no, because we have already visited this cell before we have visited this cell. That's why we have to make this cell visited such that we cannot reach to this cell into the same path. That's why we have to make every cell visited. Now, suppose currently we are presented here. Now, from here, we have to recursively call the DFS function from this cell, this cell, this cell, and this cell. So the algorithm is, at first, we are presented in a cell, and we have to recursively call the DFS function from the all of these 4 diagonal cell. Now, inside this DFS function, we will check whether our current cell is visited or not. We will do it later, but the algorithm is basically, if we present it in a cell, we have to recursively call the DFS function from all of its 4 adjacent cells, which is left, right, up, and down. Now, if after calling some of the DFS call, suppose currently we are presented here in these positions. Now from these positions, we have 4 choices. Either I can go up, left, down, or right. If I go to the right, then we will find the ending positions. Now wait, we have to check whether we have covered all of this empty cell while reaching to these ending positions. So we have to maintain one another check. And the check is, suppose currently, if I am presented in the ending cell, we have to check the number of cells visited along this path. If the number of cells visited is equal to the number of empty cells, that means we have covered all of the empty cells along this path. So from this, we have to return 1. That means we have finally called, or we have finally reached the ending positions, and we have covered all of the empty cells. If we do so, we have to return 1. So basically, this is the DFS algorithm to solve this problem. And I forget one thing. Inside each of the DFS call, we have to check also one thing, that if our current positions is in the restricted cell or the obstacle cell, from those we have to return 0. That means there will be no another path which go through this obstacle cell. So basically, this is the algorithm to solve this problem by using DFS. I hope you understood the algorithm. Now let's move on to the code. Here, the code is pretty simple. At first, we are given a function named UnitPath3, and inside this function, we are given a grid, which is the input grid. Now, from this input grid, we have to check, or we have to find the starting positions. Now, we are iterating through every cells of this grid. If our current grid element is 2, that means we have found the starting positions. So here start I will contain the value I, and start j will contain the value j. And if our current grid element is 0, that means we have find the empty cell and we have to increase the counter by 1. After that, we have to call a backtracking function or DFS function, where the first parameter is the starting I, The second parameter is starting j. The third parameter is n, and the fourth parameter is m. Both of them are dimensions of the input grid. The fifth parameter is the counter value. That means the total number of empty cells presented in the grid. The sixth number of parameter is 0. That means currently we did not visit any cell. And the last parameter is the input grid. Now, this is the backtracking function or the DFS function. Currently, we have to check, suppose we are presented in a cell, and currently we have to check if our current I and j is out of bound or not. If it is out of bound, or we have visited this cell before, in this case, we have to return 0. Now we have to check, currently we are at the ending positions, and if our total visited cell, which is temporary count minus 1, is equal to the total number of empty cell presented in this grid, then we have to return 1. That means we have found one possible way to reach the destination cell where we have covered all of the empty cells. Now, after checking these two base conditions, we have to make the cell visited, which is grid of ij is equal to 3. After that, we have to recursively call the backtracking function into the right, left, up, and down. That means in the 4 adjacent way. After calling this backtracking function or the DFS function in 4 possible ways, we have to again make this current cell non-visited, because it may be possible that from any other path, we need to go through this path also. So if we make it visited from any other call, it will not be possible that we can go through this path. So we have to make this cell non-visited again. And after that, we have to return the accumulate value of the 4 DFS call from the 4 adjacent cell, which is up, down, left, and right. Thank you everyone for watching this video. We will get back soon with another LeetCode solutions.